This lesson we are going to go over related rate. Related rates is a little bit complicated sometimes. Okay, so when we talk about related rate, everybody you have to remember. Now we are taking derivative with respect to t now. So most likely it doesn't matter you are using x, y, or z or s. Whatever you're using, those variable is a function of t. We need some formulas to set up the problem. So for example, the volume of sphere, the volume and the area of a circle, circumference, volume of cylinder, and the volume of a cone. Okay, so how do we set up this related rates problem? Number one thing you need to know is taking derivative with respect to t, and also you have to keep in mind, after you read the problem, if the number given is changing, okay, you cannot use that number to set up the equation. What do I mean by that? Let's have a look at number one. So look at my steps, everybody. Suppose a spherical balloon is inflated at a rate of 14 cubic inches per minute. So I'm going to convert this sentence. Okay, dV over dt equals 14 cubic inches per minute. That's given. How fast the radius of the balloon changing? We are looking for how fast the radius is changing. So we are looking for dr over dt equals what? Given the radius equals 7. So because the radius equals 7, this number 7 is changing all the time. As the volume becomes bigger, the radius will be bigger. So we cannot use number 7 to set up the problem. So as we know, V equals 4 over 3 pi r cubed. So this is the equation. We can take the derivative with respect to t on both sides. This is our answer. If you look at example 2, after you read the problem, this number 5, okay, with constant radius 5, this 5 is now changing. So when we set up the volume equation, we are able to plug in 5 here as r. And the height equals 4 inches. Because this height is changing, so when we set it up, we cannot plug 4 in here. So if you don't understand what I'm saying, ask me directly. We write what is given, dV over dt, and r equals 5, h equals 4. When h equals 4, what is dh over dt? So set up the equation, take the derivative. The steps are very similar. Once again, if you realize the number of the variable is changing, you are not allowed to use that number to set up the equation. One more example. So if you look at this one, this 10, that's a diameter, is now changing. Okay, we can use this number to set up the equation. And the height 9 is now changing. Also, we could use this number. Okay, how fast is the radius of the water? Because the radius of water, when the radius is 4 inches, the radius of water is changing all the time. So this number 4, you are not able to use this number to set up the equation. So volume equals 1 over 3 pi r squared h. Everybody look carefully. So r is changing all the time, right? And we have another variable h here. So if you look at the r and h are the height of the water and the radius of the water. So we cannot have two variables in this problem. So we want to express V volume as one single variable. We have to find a relation between R and H. So now we are going to use the similarity. So if you look at this line, right? So it's 9 H over 9 H over 9 equals R over 5. This is similarity. That's how we got H equals 9 over 5R. Now we plug it in and then take the derivative. Example 4. So after I read the problem, 17 foot is now changing. So when I set up the problem, 17, I could use 17 in my equation. And if you look at the variable x and y, both x and y are changing. So 8 and 15, both these two numbers. 15, you cannot use it to set up the equation. So x squared plus y squared equals 17. I take the derivative, plug everything in. Let's have a look at example 5. A person 6 feet. This number is not going to change. It's a constant, so we are able to use this number to set up the equation. 13 feet, the straight line, this is not changing. So 6 and 13, we can use it to set up the equation. So we have x, y, we are using a similarity. Okay, 6 over 13 equals y over x plus y. B, at what rate in feet per second is the tip of the shadow changing? So we are looking for how fast is the tip of the shadow. So this is the tip of the shadow, everybody. So we are looking for dz over dt. So how fast? This is the distance from the tip to the straight line, which is we use z. Okay, dz over dt is what we are looking for. How fast it's moving away from the light. And 7.7 is, I put the L'Hopital's rule here. We learned this before. For all the limit, if it's 0 over 0 and infinity over infinity, we can use the derivative and L'Hopital's rule to solve the equation directly. So everybody try to do this problem yourself and compare your answer with mine.